Howdy, howdy. So this is hardware design. We're talking about the QuadRoot unit that we've been building for the last two or three sessions. I think this is part 3. So last session we sort of ended abruptly because I was looking for the inclusion to get our DW_root module working from the Synopsys Designware library. The trick was that inside the make file, ooh, that's tiny. I don't know, 14. So the trick was we needed to add a directory to the search path for modules. And so how that works is this -y flag, and it looks like these two things are enough to get those modules in. So it's just the Synopsys root path plus DW plus SimVerilog, and then the plus include directory. So I think a combination of these two things find that directory. I think this should be sufficient to get Designware to run in Synthesis too, but we'll see in a bit. So where we are aside from that, so let's yep, so we showed the fix, so we're doing good. So we need to finish the verification is what we were doing, and last time we were in the middle of compiling, so we'll go ahead and do that now. Dun. Okay. Unused variable. So it looks like the the included square root function has a lint error in it. So that's sort of a fun problem. All right. So we can't do anything about this lint. We're gonna have to. I mean, short of going into our installation files and fixing the installation file directly, which could be a never-ending thing. I think what I actually need to do is get it to mask lint errors for certain files. So no argument for format specification. Top QuadRoot 147. All right. Well, so one problem is we forgot to include $time here. So that's, maybe that was it. I think what that error was that we had more format strings in here than we had things that we were interested in. The trick to debugging this, if this is not, okay, so that appears to be the last error. So let's try and clean up as much of the nastiness as possible. So we've never used halt, so we'll just close that out because we're not using it. We haven't used start, so we're not using that either. Let's see, lint width mismatch continuous assignment of 1 bit on the left-hand side versus 16 bits on the right-hand side. Interesting. Okay, so what is that? So it's saying that's near QuadRoot 75. So that's probably that would probably be a functional bug. Yep, FAC. Am I already using the keyword AC? Ah. Yep, there we go. And then is that enough? So the problem was FAC wasn't declared, so it assumed it was a 1-bit thing. So we fixed that. So the next question is that, well, we're looking at this expression that had an error in it. Let's make sure that it's right. And so we're left shifting C, which is a bit width big thing, by 2 plus FW. So as long as 2 plus FW is smaller than bit width, this should be fine, because we've allocated FAC as being 2 bit widths across. Okay, so that should be fine. It implies 0, so that's probably not exactly what we want, but there's worse things that we could do, and we probably want the zeros in there anyway for when we do the subtraction. Okay, perfect. So let's see if that cleaned that up, because it could produce new errors. All right. Sorry if that cut in and out. I think I hit a button I shouldn't have hit. If it didn't cut out, good. So we have a lint. Ooh, we have another compiler directive encountered. So these aren't actual lint errors. These are, I've set a note somewhere to include all compiler directive indications, because a long time ago I got bit hard by somebody adding compiler directives in and disrupting the flow of compilation in other Verilog modules. And so now I print all of them out so I can see them, and I've just included that in. It makes counting lint errors difficult, and we still have this lint unused, so we're good. So we've done comp. Let's run, make sure. Yep, so we're wrong. Let's go look at top QuadRoot. So let's see, B and C. Okay, so this isn't, okay, good. So it's not a floating point problem. For a minute I was spacing out and thinking I had had a floating point issue and thinking too much about a floating point test bench. So let's go super easy here. So let's just create a variable int b equals, and we'll say 4. So then minus b, and b. Okay. forgot the semicolon. Suppose I've been writing too much Perl, not Perl, Python, and not including semicolons. All right. Well, that's problematic. So it looks like we're printing during reset, and then we're stopping. This isn't 16 things. 1, 2, 3, 4, 5, 6, 7, 8, 9. If reset display okay, good. So we're not printing while we're in reset, so it appears that something is getting set to X. And that is because we have accidentally reused B. So we will call this B and D. Actually, I have to be clicked into the window. There we go. So I think the conflict was causing X's. If not, we have actual X's in our design. So there we go. So now we have actual conflicts. So B3, C3. So this would be X squared plus 3B. So R0 valid. R0Z. So no, that didn't work. R1 valid. R1Z. So no, that didn't work. So this is a really suspicious number. This looks almost like -1. So let's do, instead of decimals, give me X's. R00X. There we go. So let's see. Because it could be a rounding issue, and so we're really getting like -1 or -2. But since everything is not marked signed, I don't think I could be running into problems there. Nope. I seem to be, though interestingly, I seem to be getting more or less the exact same numbers out, which is worrisome. Yeah, so I appear to, so let's check. Is it different between 2, 2 and 3? 3. This is going really well. So yeah, it seems like it's the same. No, they're a little bit different. They're a little bit different. Okay. So one problem is that I think there's a bug in this code, because this is supposed to be J. So that fixes that problem. So the problem was that we had written I twice, then it should be ij, so that's why the loop variables were tracking each other. We should go through 0 though. 4 minus 3 minus 2 minus 1, so there should be up here a 0, 0. Good, so we got a few right. That you know, the 0 happens at 0. This is concerning. So this is x squared minus 1. Which should only have, which should have no valid, yeah, so this is x squared minus 1. It should have no valid outputs, but it does. This is minus 2. So yeah, so this is a hot mess. Alrighty. So the thing to do is to build some debug in. So what we're gonna do, we're gonna take a look at QuadRoot. And what we're going to try and do is write all of the numbers in floats. So what we want to do here is, you know, for each signal, report decimal value of string. Report equivalent floating point value. All right. So right off the bat, what we're going to do is we're going to kind of fold this, unfold this expression to make our life easy. $right 10t. By 100. $right. B. That's right. Begin. And so this will be very, very boring. C, we're going to do %60 again. C. And maybe to make this a little more legible for ourselves, we're just going to do one of these, because we're gonna come back and we're gonna fill these in with floating point values. So we have C. And we're going to grab R0 and R0 valid in one chunk. R0, R0V, dollar right /t/t R0 0 %6D R0, and this was R0 valid. That could have been bad. Oh, come on. And this is R00. And then we're going to do the same thing for R1 in a bit. So repeat for R1. Okay. And then, so I promised we'll need to display the real value. So, you know, we need to look up. So we went $I to R. I'm going to put B in there. And then we need to multiply it by some coefficient. And then let's make this 2.0 so that we're getting this right. Do the same for this. Do C. That means I want the floating point value here, so Verilog. So it's been a long time since I've actually displayed a real. So hierarchical name, decimal format, binary, hexadecimal, ASCII. Real. Okay. I'm not seeing it in the list. Verilog display real. For real numbers. Looks like it's the same as C. We use F. So we'll do something like O2 dot to F percent O. So let's do like 4. 4F percent O 4.4F, and then this is before that, so we gotta add our $I to R, R0. We're gonna do our fun multiplying it by some power of 2. Make sure we keep the comma there. And same trick. I to R. R0 under 0. good. So we just need to figure out what the actual shift needs to be. So we want to look at we should just look at this module. So its fraction width is what we're going to do. So this would be $FW. This is $FW as well. And then it looks like R0 and R1 are also that. So we should get a result that looks like that. And then the R00 is 2FW. 2 times FW. And then we just need this chunk of code again for R1. And here we need to be very careful. I think I got them all. Okay, so now let's print this out. Repeat for R1. So that was our intentional typo to force the error to help us remember. I think I lost my window in case people had questions. Ooh. No argument for format specification. 1, 2, 3. 1, 2, 3. Ba-ba. All right, so what's going on? It's only 2 lines, so the same 2 lines. Okay. So it's just the 2 lines. We've done these 2 lines before. So how is this line different than one of these lines? Oh, so we have an extra comma here. So that was the difference. Cool. Cool. Welcome. We are slowly but surely debugging our QuadRoot unit that does not currently output sensical values. We forgot to make these negative, so they are all way too big. So let's try one more time. So right now what we're trying to do is create nicely. Did I forget to save the file? Definitely made those negative. That's right, this is one of those languages where they don't like the trailing, the failure to trail a zero. Alright, because it's not clear if that's a dot for something else or if it's a dot for the decimal point. All right, so this just looks wrong. So we know that the LSBs are 3. So this represents something like 3 out of 8. Is that what our defaults are? No, that's sort. This is QuadRoot. Yeah, our defaults are 8. So that's 3 out of 256, which should be a small number. So why is it printing like that? So we're taking 3. So let's do something silly. We'll just delete the first one here. So it should put out 3.0. It's not outputting 3.0. I'm not sure what's going on. Oh, excuse me. Okay, good. It says 3.0. Good. That one says 0.01117. I suspect it might be caching things. Okay, good. So now we have what we expect. So it's giving us a negative number. You know, we know that that's not true. You know, let's go to QuadRoot calculator. Quadratic equation. Calculator. So I guess there's one at math.com. So we put in 1, then we put in 0.117, 0.117, hit solve. Yeah, we should get imaginary things. Okay. So good. It should be telling us it's imaginary, but it's not. Okay, so at least the numbers here not making sense. It is a problem. Okay, so why might it be saying that it is not? let's look at the intermediates. So let's open the other guy here. So we have BSQ. So we'll look at BSQ and we'll look at FAC. Again, that and that. Though this time it is going to be my under QuadRoot dot BSQ. And this is going to be my under QuadRoot dot FAC. These are interesting because they are both 2 times FW. Oops. No, it eventually sorted itself out. Yeah, I was doing it poorly. Oops, and I left the C in here, so it's having fun with that. B square, FAC, cool. So yeah, these debugging these things can be brutal. Because I didn't see an obvious place for this to go awry. All right. So 0.0117 squared, yeah, that's about 0.001. 0.0117 times 4 is going to be 469, so good. So that's working. All right, so we got this far through the code. So then we're going to take the difference of those things. I doubt that this is going to be broken, so we're going to skip that. Oh, but we're looking at the difference. Okay. So we do actually want to see the difference because that'll tell us how we're doing here. So we'll write diff, and then this is DIFF. It is still in that format, so that's good. Ooh. Is it possible I forgot to make something assigned type? All right. B square 9, fact 3072, so we get minus 3063, which is minus. Great, so diff is diff. So it is these. These are what are getting us in trouble. And we are comparing to 0. And it is inferring that the zeros are unsigned, so it is converting diff to unsigned, and that is what is killing us. Great. So $signed. This is a hoot. $signed. I mean, at this point, it should almost be a signal, because the amount of work that is going into figuring that out. Cool, cool, cool. Slowly but surely. Yay! So now we fixed our valid issue. Okay, so let's see how we're doing here. So if reset and 1 bit 0. So we're just going to see if we have tons of errors. Just as a quick sanity check. Because if we lucked into having them all work... No, so we didn't. Okay, so we should cover this up a bit. Cover that up a bit. Because we know that that works. So now what we're interested in is these sort of the diff to these values. So before we get too far, I know you don't think you ran, but something did change. I just didn't save the file. All right. So forgot to remove our little trick here to turn that off. Apparently being too clever for myself. All right. So it's producing some numbers. Good for them. All right, so we're going to need to scroll a bit higher to look for the valid ones. So what we will do, if reset and R0 under valid and R1 under valid. Go. And so this is, so we already know that that is true if we're in here. So then this is if R1 under valid, begin, end. So this should clean it up. So I think a video ago I said that more likely than not we'd need to start playing around with the floating point version of these and then just talk about SNR. That looks like where we've ended up. So if b is 3, so x squared plus 3x. So one of the roots is 0, one of the roots is minus 3. So yeah, so that checks out. So minus 3 squared is 9. Minus 9. Okay, good. And then the trivial 0. Good, 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 good. So that one worked. It was upset about this one at 610. So yeah, we're dividing by hundreds. This was 610.01 picoseconds, failed. So it is saying, so our inputs were 3 and minus 1, so x squared plus 3x minus 1. And the difference was 0.0158. Okay, so that seems big. What is a 16th? Divided by 16 is, no. So 1 over 2 to the 16. Yeah, so that's 4 zeros. Okay. So it's wrong. So we could have gone wrong in a few places. So we know diff is for the most part correct. So maybe we've used the square root module incorrectly. You know, that's fairly probable. So we asked for a 2-bit with -1. I think we turned off 0. So what did that do again? So I think that echo dollar synopsis good. So there's a DW directory. Boo. Examples. No. Square root. Instance.v. 2's complement mode. Huh. Ha ha ha. Why would it have a 2's complement mode? So diff should always be positive. There's even a nice note here saying, please add this line to your code. The problem is you wouldn't know to include directory for this directory unless you knew that this directory is where to look. All right. Sure, I don't think that's going to magically make our answer right. So we're just going to print out diff root. Called it diff under root. Diff under root. Since we took the square root, what should happen is that it should divide the implicit shift by 2. So there we go. It's like it's back to FW. Let's see how we did. My impulse would be to say that the unit is correct. I am either using it wrong or I do not understand what it does. So yeah, spot on. The square root of 9 is 3. Good work. The square root of 1033 is 32. So yeah, that checks out. So that's a pretty close to 0, and I think it's writing 1 there because it's rounding. So what we actually want to go do is, in this guy, we want to write 5 and 5. There we go. So actually, let's make it an even 6. So I suspect where we're at is that I was misreading the earlier results and that this wasn't wrong, it's just imprecise. And it's imprecise to the 4 zeros, so that's what we're looking for, is 4 leading zeros in the residual, because that would be a rounding error, right? Because we're flooring, so the biggest error could be is 1 out of 2 to the 16. So those are definitively 0. So that's 3 zeros. Okay, and that's 3 zeros. That's 3 zeros. That's 3 zeros. That's actually 0, so we hit it perfect. That's 4 zeros. That's 3 zeros. So we seem to have some noise that could be as big as minus 40. Oh, I only have 8 bits of fraction. But I'm displaying a result higher. So I think what we really need to do is we need to come up here and we should just rewrite these checks. So I'm pretty sure it works now. I think what I messed up was just reading the outputs. So 1 out of 256 is, so how many zeros should that be? Divide by 256. So 2 zeros. So we're actually seem to be doing, at least in the cases that it was yelling at me about, really well. Okay. So R00. So it appears that I am having fun with doing math twice. R00, R1 under 0. These don't have any precision errors in them, but they are 16 bits more, 8 bits more precise than we were before. So what we're going to do is $I to R. So what we're actually interested in, and then do I have an abs? So I'm going to peek in that directory because I bet there's a oh, there's not an abs unit. Okay, thought they might have a shortcut. R00 greater than 0. Since we don't actually care about which way it is, we're just going to write it out in absolute value, greater than 0. If it's greater than 0, do that. If it's not, do this. Good. We should do the same with R10. We should assert that this is less than 2 to the 8, so 2 to the 9 minus 1 is, I think, where we're at here. It's 2 to the 0, so I think this is actually 2 to the 8. And then it's mad because I did something with a parentheses that I didn't need. Probably duplicated that mistake. There we go. So this is, so it looks like it may have just been, could have swore I got rid of that. All right. Dun, dun, dun. Man, you are upset. Because I just deleted the wrong paren. So I am much more productive at programming in the morning, but I suspect if this was early in the morning, nobody would watch. And I suspect it's much less helpful if I am on top of what I'm doing and it just magically works. Debugging the mistakes I make when I'm tired is probably a little easier. So we appear to be working. Okay. Yeah, so what we changed this to is we said, oh, since we are calculating a difference, but we're doing it at a higher precision, there's a possibility that some of the lower bits will be non-zero. So we're just saying that the difference needs to be less than the amount that we shifted in, because there's an extra fraction within there. Cool, and that appears to work. So let's see. And then we're just gonna block all this out for a second. So you guys have gone away. Maybe it'll get mad at us for having a pointless always at pause edge block, but technically we're doing something. I doubt the tool is smart enough to print stuff like that out, because that would be an example of bad coding style. All right, so it looks like we're passing that test so far. All right, let's make our bounds bigger. So let's go, 1024. Cool. So it doesn't work. Cool, cool, cool. So it seems that we have managed to find some test cases that break this. So we're going to put this back down to a smallish number. So we'll do something like 64. And so we want a random butts fall, random stimulus. Okay, good. Where's my notes? Okay. Check our zero comparison. So I think we're still at this point. So we fixed some things. So we saw some typos. We printed things out. We double checked that it worked. We kind of got the display working. The real issue was our zero comparison. Was a little overly sensitive, is that you can't say that it's exactly zero. So this is sort of done, but I'm a little bit concerned that I have so many errors. It's hard to believe that I am this consistently wrong. So some of what we're going to be checking is, we need to come back to this, and we need to, double check the 2 to the FW constraint. Maybe it's actually 2 to the FW plus 1. I doubt it. but it could be. You know, so what are these? What do these errors look like? Yeah, and then we need to add a test to see if the root counts are wrong. And I suspect the way that we're going to do this is like a $I2R thingy that just does the equation. Q and float. Then A and B, or sorry, R0 and R1 should be, you know, within 1/256th of that answer. Or, you know, 1 to the 2 to the FW of that answer. And then run it. So these could be overflow scenarios where the root is really large, but I doubt it because we're iterating over small numbers. Because I think the way that this should work is that it is only large if those two parameters are large. But you know, we'll play around with it. Cool. So that's it for me. Thanks for tuning in, and you know, feel free to post questions in the comments so they give me a ping whenever somebody comments on my videos, and I try and answer those there. You know, so feel free to post questions here about the video if you have any. I think this probably has another couple sessions because it seems like I'm getting really bad at debugging this unit. And one of the questions we had was how big was the square root? So I think we have some experiments that I wanted to talk about, just synthesizing these things separate if I don't get to it in like a side channel exercise. I have a homework assignment I've given myself to go measure these things in 7 nanometer anyway. So maybe I will accidentally produce those results and I'll just show you the figure when I'm done. Okay, well, I hope everybody has a great Wednesday night. Thanks for tuning in. Thanks for the comments, Ellen, and I'll see you all next time.